I'm Dr. Danielle Lambrick. I'm a lecturer at the Institute of Food, Nutrition and Human Health at Massey University in New Zealand. Exercise economy is a key parameter in the assessment of an individual's aerobic fitness. Now, the current definition of exercise economy is the metabolic cost per kilogram of body mass at a given exercise intensity. However, children of differing body size don't exercise at the same absolute intensities. They exercise at a metabolic rate which is scaled for their body size. A recent review article in a pediatric exercise science journal has suggested that exercise economy should be interpreted relative to body size, for example, considering factors such as leg length, stride frequency, mass and stature. However, research in this area in general has yet to consider the differences in VO2 kinetics responses between individuals, and it has some implications for exercise economy. For example, at a given absolute treadmill speed at 8 kilometers an hour, one individual may be exercising below their gas exchange threshold, a moderate exercise intensity. In this domain, their VO2 response will achieve steady state. However, for a second individual, this treadmill speed may be above their gas exchange threshold, a heavy exercise intensity. In this domain, the steady state VO2 response is precluded by the addition of a slow developing component of VO2, something termed the VO2 slow component. Now, given the calculation that exercise economy is based upon oxygen consumption at a given exercise intensity, the subsequent comparison of these two individuals would be inherently flawed. As such, the purpose of our study was to assess the exercise economy of children of differing body mass at relative exercise intensities, moderate and heavy, during treadmill running. So following institutional ethical approval, we had 18 healthy normal weight and 19 obese children take part in our study. They all took part in 2 exercise tests, both on the treadmill. The first was a maximal graded exercise test to peak oxygen consumption. This test also allowed us to identify individualized gas exchange thresholds for each child. They then took part in a submaximal exercise test, which comprised a 6-minute moderate intensity constant load bout at 90% gas exchange threshold, followed by a 6-minute constant load heavy intensity bout at 40% of delta, which is the difference between gas exchange and peak VO2. There was a 5-minute recovery period between those 2 bouts. Now, the main findings of this study are that our obese children were more economical than their normal weight counterparts. Furthermore, all children, regardless of body weight, were more economical at the heavy exercise intensities. Our findings are highly novel in this area of research, and I look forward to presenting some of the physiological underpinnings and the implications of our finding at the ANZOS conference. Thank you.